In terms of heat, there are two major kinds of chemical reaction. It's either you have exothermic reactions or you have endothermic. We'll talk about what all of that means in a second. Energy cannot be created or destroyed, but can only be transferred from one form to another. So everything you see around you, every form of chemical reaction, it's not like the system manufactures energy by itself. No, the energy comes from another store. So you have translation and all of that. Even in a case of a cup of coffee that loses its heat or becomes cold, the energy goes into the environment, dissipation. So it's not like lost. It has just been transferred to the environment. You get the logic. So exothermic basically releases heat, energy to the surroundings, while endothermic absorbs heat from the surroundings. So let's say you have a conical flask now. If you touch the flask and the flask becomes hot to the touch, that is exothermic because the reaction system has released heat. That's why you can feel that. Example, combustion. So the temperature of the surroundings rises while endothermic absorbs heat from the surroundings. So it will be cold to the touch. An example of that is cold packs. So the golden rule is this. If the temperature of the surroundings rises, that is exothermic. And if the temperature of the surroundings falls, that is endothermic. Combustion is exothermic. For those of you who don't know what combustion is, so combustion is basically when a substance or a chemical burns in oxygen. So literally burning. So anything that burns has combusted. Photosynthesis is an example of endothermic reaction because when that happens, temperature falls. Neutralization is exo. In fact, there is a required practical under this energy change topic that we're looking at that requires you to perform neutralization, and you try to figure out the highest temperature that the reaction medium can reach, and then you record. Thermal decomposition is an example of endothermic reaction. Yeah, temperature falls, it absorbs heat from the surroundings. All right, so when it comes to combustion, an example of exothermic, when you burn fuels, wood, gas, petrol, it releases heat to the surroundings, and you tend to have it used in engines, boilers, planes, and all of that. Neutralization, like we said earlier, is an example of exothermic reaction. If you have HCl, that's hydrochloric acid, reacting with sodium hydroxide, that gives you your salt and water and heat. So if you perform the reaction in a conical flask and you touch it, the conical flask will feel hot to the touch. In fact, you can even attach a thermometer. The thermometer will keep on rising until it gets to the highest point and then falls back. Always exothermic. Neutralization is always exothermic. Keep that at the back of your mind. Then hand warmers. If you react iron powder, if you burn it in oxygen or it's just exposed, it produces heat and iron 3 oxide. Respiration will make your body releases energy from glucose. So when the oxygen breaks down glucose in the body, energy is released. Carbon dioxide, water, and energy. Freezing is also exothermic. So when the liquid becomes solid, the particles lose energy and slow down. Energy released to the surroundings. Thermal energy is taken from the substance the substance gets cold, or we can say the substance loses heat. Now for endothermal decomposition of limestone into quicklime and carbon dioxide requires heat continuously for that reaction to go into completion. Thermal decomposition itself, you have a bunch of reactions that can go through that process. But the point that we're making here is that for that reaction to go into completion, you have to keep on supplying heat. It's an endothermic reactions. And remember what we said, endothermic reactions, what they do, what? They absorb heat from the surroundings, or it could be from another external source. Photosynthesis is endothermic. It absorbs light from the sun. Or we can say light energy. It absorbs it from the sun and then uses it to jumpstart that chemical reaction. Spots cold park. Ammonium nitrate is dissolved in water. It absorbs heat and then it causes injuries instantly. Then you have electrolysis, that is when current is passed through an electrolyte and it decomposes, technically, that is, it separates them into cations and anions, and all of the other processes happen. So it is used to extract aluminium. All right, not only aluminium, anyways, but on your reactivity series, all of the elements above, all of the metals above carbon on the reactivity series, electrolysis can be used to extract them. Dissolving, yeah. When you dissolve ammonium nitrate in water, it absorbs heat from the surroundings. So don't forget the basis of everything that we've talked about in this video.